Okay, so we're in section 2, chapter 5, and the topic for this section is a few different formulas, what we call the sum and difference formulas. So what I've done is I've parked these sum and difference formulas that these are taken from your formula sheet, but I've parked them here so that you can apply them. And what we're going to do is, this is going to be a fairly short video, I hope. But basically this section is all about how do I use these formulas. Fairly easy. Normally what I do is, because it's almost impossible for me to give you a formula without showing you where it comes from. But you guys are lucky since you are not in my lecture class or my online class. So all you have to do is just please pretend like you're interested for just a second. Where do these come from? What is this? Where do these sum and difference formulas come from? So really quickly, this won't take me long at all. You don't have to take any notes here. Are you ready? So take a look at, we have point P, we have point Q here on this circle. Now there's some angle that called beta that point P is made, and there's some angle alpha that point Q is made. And now what I'm going to do is I'm going to connect a line from P to Q, or Q to P, right? A segment. So you can kind of see that here. So nothing's changed. I've just connected a line segment from P to Q. But here it is. I'm interested in this angle. What is the angle between P and Q? All right, now almost there. So can you imagine? This is hard to visualize. So what I'm going to do is pretend like this circle here, right? Imagine this is a volume knob on your stereo, and you know how you can turn it to the left to turn it down, or turn or right, or turn whatever it is, and to turn. But you can turn this knob. So what's happening is, just imagine that I've turned this knob so that P is going to move all the way to the x-axis, right? So notice that now point P is down here, and here's the new location for Q. But will you agree with me? Will you agree with me that just because I turn the knob, this distance from Q to P, that's not going to change, right? The distances are equal. So what I'm going to do, in order to get to these formulas, I have the proof on the next page. I'm not going to go through it step by step. You can do that on your own time. But it's very simple. All we do is we take this distance, set it equal to this distance, and we just simplify. So notice that, here's our distance formulas. So graph A, that I have P to Q. Here's the distance formula applied to graph A, and here's the distance formula applied to graph B. And simple enough, if you set P to Q equal to P to Q, that's exactly what you have here. Set your distances equal, square both sides, that gets us to here. We subtract 2 from both sides, gets us to here. Divide everything by -2 gets us to here. And now take a look at what I have here. Cosine of alpha minus beta is equal to cosine of alpha times cosine of beta plus sine of alpha times sine of beta. This is exactly what you have with one of these distance formulas, right? So that's where they come from. Now, the good news is all you need to be able to do is know how to use them. So how might a question look if you need, and when would you need to use these? So very good question. Are you ready? So assume that you want to find the exact value of cosine of 15 degrees, right? Cosine of 15 degrees. Let's notice a couple things. So if a student put cosine of 15 degrees in their calculator and pressed enter, and then they wrote me a decimal, some decimal here, right? I would just mark it wrong, because I'm not interested in an approximation of cosine. I want the exact value of cosine of 15 degrees. So what you would do is you would, normally when you want exact values, we look at our unit circle. But tell me, is 15 degrees on your unit circle? No, it's not. It's not 15 degrees. So what do? How do we find the exact value of cosine of 15 degrees if cosine of 15 degrees is not even on your unit circle? Well, if you were taking this class, I don't know, 40, 50 years ago, you would have, along with your textbook, you would have purchased a second book with this class. And that book would have kind of looked like a dictionary. And you would have been able to look up cosine of 15 degrees, cosine of 14 degrees, cosine of 13 degrees, cosine. It would have had all of these exact values for various problems. But here's a way of getting to the exact answer without looking it up. Ready? So we want to choose. We want to rewrite cosine of 15 degrees. We want to rewrite this as cosine of, let's do some alpha minus beta or plus beta. Doesn't matter. We want to start to think about it in terms of two angles. Now, if you're paying attention, you would say, but professor, there's a whole lot of things that you could add to get 15, right? Or subtract to get 15. So for example, 50 minus 35 is 15, right? Or you see where I'm going, or 25 minus 10 is 15. But we want alpha to be an angle on your unit circle. And we want beta to be something on your unit circle. So watch how I'm going to do this. I'm going to let alpha equal 60 degrees because 60 degrees is on your unit circle. And I'm going to let beta equal 45 degrees. Now, don't you agree with me that 60 minus 45 is 15? Right? So don't you agree with me that now I can rewrite it as cosine of 60 degrees minus 45 degrees? That's the same thing. All right, let's now grab that formula from the previous page. We're going to look at it. So bear with me here. So we're going to look at, that is cosine of alpha minus beta. And notice how we can rewrite this as cosine of alpha times cosine of beta plus sine of alpha times sine of beta. All right, so let me go ahead and write it. So that's going to be cosine of alpha, that's 60 degrees, multiplied by cosine of beta plus sine of alpha, so sine of 60 times sine of beta. All right. So if you allow alpha to be 60 and you allow beta to be 45, then you see I'm just plugging them into the formula. Now, is cosine of 60 degrees on your unit circle? It is. So cosine of 60 degrees is 1/2. What's cosine of 45? Yep, it's the square root of 2 over 2. Now, what is sine of 60 degrees? It's the square root of 3 over 2. And sine of 45 degrees is the square root of 2 over 2. All right, let's just finish this up and we will be done. So let's start here. So 1 times the square root of 2 is just the square root of 2, and 2 times 2 is 4. So numerator times numerator, denominator times denominator. So that gets me to the square root of 2 over 4 plus, all right, well, let's take a look here. So the square root of 3 times the square root of 2 is the square root of 6. And of course, 2 times 2 is just 4. So again, numerator times numerator, denominator times denominator. All right, so we can write this, and honestly, I'm fine once you get to here, square root of 2 over 4 plus the square root of 6 over 4. But we can combine them. We could write that as the square root of 2 plus the square root of 6 over 4. Please understand, this is the answer I'm looking for. Honestly, if you write a decimal in this class, it's probably wrong. It really is. Your answer will almost never be a decimal, unless it's a word problem, and I will tell you that what to round your answers to. But this is the answer. This is what I'm looking for. All right. So now let's see if we can work these formulas going the other way. So you're asked, there it is again, the exact value. Find the exact value of, now it's cosine of 80 times cosine of 20 plus sine of 80 times sine of 20. The hardest job, in my opinion, is going to be you picking the right formula. So that, remember, this is cosine times cosine plus sine times sine. So you have a whole lot of you have 4 options, right? So you need to figure out which one of these we can use. Remember, it was cosine of 80 times cosine of 20. So cosine times cosine. So notice this has cosine times cosine, so does this. But it was plus sine times sine. So we want to use, this one is the current form. And therefore, we want to write it as cosine of alpha minus beta. All right, so the correct formula to use is cosine of alpha minus beta. Okay, so at this stage, let's just determine what is the alpha and what is angle beta. So in this case, alpha would be 80 degrees and beta would be 20 degrees. So let's plug those in. We have cosine of 80 degrees minus 20 degrees. Or in other words, cosine of what? 60 degrees. Now, is 60 degrees on your unit circle? It is. So cosine of 60 degrees, we can look that up. That is equal to 1/2. And we're done. All right, so that there's not, in due reality, there's not a lot more to this section. We're going to go ahead and conclude because your answers are going to have, your questions are going to come in one of two forms. Either you're going to be, it's either going to come in this form or it's going to come in this form. But there's not a whole lot more to the theory. So the only thing left to do is just to get a little bit of practice. But I think you'll agree with me that this is fairly straightforward and fairly easy. So I have faith that you'll get all the practice you need from your homework. And we'll go ahead and conclude the section. If you do happen to have questions, as always, just reach out to me. But I think this is enough of a tutorial to get you through this section. See you in the next video.